Hi everyone, thank you so much for joining today. My name is Alba Rivas. I am a developer advocate at Salesforce, and today I'm going to talk about how you can use the newest ECMAScript features in Lightning Web Components. So let me open my presentation. Here we have, these are my contact details in case that you want to contact me later. I am on Twitter, and also you can reach me on my email. Also, I will be responding questions at the end of the presentation on the chat window. So if you have any questions, you can ask them there. Great. So this is our favorite slide, the forward-looking statement slide, which just means that Salesforce is a publicly traded company and you should make purchases based on the functionality that's generally available, but that is the case for all the features that we are going to talk about today. And this is the first webinar of a series. I wanted to do a series because I could do it maybe in 2 hours, but I think it's going to be a super long video, so I have decided to divide it in different pieces. Today, we are going to see the basics for everything. We are going to understand the terminology around ECMAScript and JavaScript. We are going to see how the Lightning Web Components compilation process works and how runtime execution works, loading polyfills from when some of the features are not available in older browsers. And we're going to see the implications that has on using the newest ECMAScript features in Lightning Web Components. We will also talk a bit about Lightning Web Components outside of the platform, and this is all that we are going to see today. In the next webinars, the following webinars of the series, we will spend some time talking about ECMAScript 9 to ECMAScript 12 JavaScript features that we can use in Lightning Web Components. Great. So first of all, of course, we need to start talking about Lightning Web Components, right? Lightning Web Components, we always say that Lightning Web Components embraces web standards, and we say that in two main senses. First of all, we have one pillar that Lightning Web Components is embracing, which is Web Components, right? The Web Components standard, which is composed of the custom elements specifications, Shadow DOM, etc. I have a couple of the other videos talking about Shadow DOM and other Web Components standards. But today we're going to focus on the second pillar of web standards that Lightning Web Components embrace, which are all the ECMAScript specifications and the features that come in the different specifications that are published every year. So normally the World Wide Web Consortium is the organization that takes care of Web Components standards, and we have also the ECMA International Organization, which is the one that takes care of ECMAScript specification. It happens that Salesforce is a member of both organizations. We have members in Salesforce teams that are taking care of web standards internally, but also in those organizations contributing and being a voice there, right? That's the reason we are so interested in spread the knowledge about web standards and about what you can do with them as of today in Lightning Web Components. So first of all, I want to clarify some terminology around these topics because there's usually a lot of confusion. First, when we talk about ECMAScript, right, we need to understand that ECMA International is the organization that creates and publishes standards, web standards. But not only ECMAScript standards, other standards as well. If you go to their webpage, you are going to see that they have a huge list of standards they are working on. Then, inside ECMA International, we have TC39. This is the committee that is focused on elaborating the ECMA 262 standards, and I know others as well, but as this is the one that we are going to talk about today, I wanted to mention that is this committee the one in charge, right? And it's really built of JavaScript developers, expert JavaScript developers that want to elaborate new features of the language to make us much more productive as developers. Then we have ECMAScript. ECMAScript is the standard that JavaScript follows. It's also known as ECMA 262. And here I leave you the link to the live edition, the one that is being worked on at the moment, and then links to the previous edition as ECMAScript 2020, 2019, etc., till 2015. I leave you here the link to the 2015 edition because this was a major update. It was the update in which all the modern JavaScript features came, as for instance classes, modules, arrow functions, the use of const and let for defining variables, etc., etc., etc. It's one of the biggest releases that we have had, I think the biggest one. And for the others, it's interesting to know that the live edition is the one in which the Technical Committee 39 are working during the whole year till June arrives. Normally in June is when they stop working on the standards. They take a picture of the standard as it is at that point, and that is the resulting ECMAScript 2021 or 22 or whatever year it is edition for that year, right? So then we have also feature stages. So every feature that is going to be part of the ECMAScript standard goes through several stages. First of all is stage 0. It's when the idea has been identified and proposed to the committee. Then the feature goes to proposal stage, which is when the committee expresses the interest to investigate and explore the specification drafts, and they start doing that, right? Then the next stage is draft, which is when the committee obtains a rough draft in which the overall approach and APIs, etc., is defined, but there are some things to define and to complete at that point. Then the feature goes into candidate stage, which is when we have something much more definitive. All the semantics, syntax, and API are defined, are complete, and we say that the feature is ready to be tested. And then there is a period of time in which at least 2 JavaScript engines implement this feature and runs tests against them, right? That way, they are going to be able to provide feedback to the committee, and that way the finalized specification of the feature is going to be elaborated. That's when the finished state is reached. Why do I explain this? Because normally, when we have the ECMAScript version, whatever, there are some features that are going to be in stage 4, which are going to be mainly those that we wanna adopt, right, as developers, and there are going to be some features maybe in stage 3 or the previous stages that we don't normally use, but that in some cases, some JavaScript engines decide to implement in an experimental way, for instance, or because they need it. For instance, in Lightning Web Components, I know that we are using decorators, which is on stage 3, and also public class properties. Great. So I mentioned JavaScript engines, and we need to follow with our terminology description. When we talk about JavaScript, we are talking about the language, the programming language that conforms to the ECMAScript specification. And it happens that there are many JavaScript engines out there, and each JavaScript engine adopts the new features in different rhythms, right? Some of them are able to keep up to date with the cadence in which the ECMAScript features are published, and some of them are a bit slower. That's important to know because we're going to see that some browsers are going to be able to support these fancy ECMAScript features that we can use, for instance, in ECMAScript 12, but some other browsers won't, and that's something that as a developer you should understand and bear in mind. Some famous JavaScript engines are V8 for Google Chrome or other Chromium-based browsers, SpiderMonkey for Firefox, JavaScript Core for Safari, and Chakra, which was the ones used for Microsoft Edge before they adopted the Chromium-based browser. One way of knowing if a JavaScript engine it's able to support a feature that is defined in the ECMAScript version whatever standard is taking a look at the test 262 report. This is a report that runs the conformance test that we have, that the TC39 committee has for all the different features, and normally all the continuous integration processes for browser implementations run this set of conformance tests, and also Salesforce runs them internally to make sure if we are complying with those features or not, right? So, after this explanation about terminology, then we arrive to the bigger question in this presentation. Can I use ECMAScript XX features in Lightning Web Components? And we are going to see that to explain that, we need to understand how the Lightning Web Components compilation process works, and also certain things that we do at runtime to ensure backwards compatibility for our Lightning Web Components applications. So first of all, I want to explain the concept of transpilation, if you are not familiar with it. Transpilation consists of transforming certain syntax features that are written on a ECMAScript version that may be, for instance, ECMAScript 6 or 7 or 8, etc., to an ECMAScript version, a version of the same language that is lower. In this case, for instance, we are taking as an example an arrow function that is defined using a feature from ECMAScript 6, and we could say that we transpile or transform that code down to ECMAScript 5 by doing this, transforming the arrow function into a regular traditional JavaScript function. Why do I explain that? Because that's something that we're going to do in the Lightning Web Components compilation process and that you need to understand. So in the Lightning Web Component compilation process, normally we start from the JavaScript file that defines your component. Then we are going to run the linter. When you push your file to the organization, all this is going to happen. First, we will run the linter, and we're going to use the base configuration for that. Then we are going to run a parser, Babel, and the parser is going to detect if there are any syntax error in your code. How the parser works is it reads your JavaScript code and it identifies the syntax features that you are using. So for instance, if you are using an arrow function, it's going to say, okay, I know this syntax structure. This is an arrow function from ECMAScript 6. And then this parser is going to say, okay, there are no errors. But it may happen that the parser finds an extractor that it doesn't know, and in that case, it will throw a parsing error. That's not going to happen very often because we try to update the parser of the Lightning Web Components compiler very often. So normally you are not going to hit parsing errors. Then here the diagram is divided in two branches because we are going to generate two outputs. Why do we generate two different outputs? Because we wanted your Lightning Web Components code to work not only in modern browsers but also in some older browsers that don't support ECMAScript 6 features. Thus, there is a branch in which what we do is to transform ECMAScript 6 Plus features, syntax features, we are talking about syntax features, to ECMAScript 6, and that is the code that we are going to use in modern browsers. And there is a final bit here in which what we do is that JavaScript code, we bundle it using rollup with the compiled template and CSS files. We do that because at the end, the markdown is generated dynamically using the JavaScript file. If you take a look in Chrome Developer Tools at the JavaScript file of a component, you are going to see that everything that's defined on the template and on the CSS file is going to be specified in JavaScript because we are going to recreate the component dynamically that way, right? So the second branch is the one that will generate the output that will be used in compatibility browsers. Those browsers that are not able to support ECMAScript 6 features, as Internet Explorer 11, for instance, and other experiences, right? So one note here is that when we say that we transform syntax features from ES6 Plus, we are really saying that we transform a subset of those ECMAScript 6 Plus features. We transform features including ECMAScript 7, 8, rested spread properties, and class fields. That's something to remember because that's going to have some implications. If I ask this question, I say, can I use ESXX syntax features that are not transformed in Lightning Web Components? Because for sure, these ones that are going to be transformed, they are going to work both in compatibility or in modern browsers. But what happens if I want to use a syntax feature from ECMAScript 12? And the answer is that yes, they are gonna work, but they are gonna work as long as the parser supports it and the browser supports it. If we go back to our schema, we are going to see that this step of parsing is very important because if the parser has not been upgraded, it's not going to understand that that syntax feature that you are introducing exists in a higher version. But as I told you, that's something that doesn't happen very often because we try to keep the parser up to date. So finally, what's going to happen? That if your browser supports the syntax features that you want to use, then yes, you can use it. It doesn't depend on Lightning Web Components compilation. This is a table in which we are going to use this table along all the series of webinars, and these are all the features that I'm going to explain during the series that we can use in Lightning Web Components. And the ones that I have highlighted in green are those syntax features that I say that you can use as of today, as long as your browser support them, right? For instance, if you want to use optional chaining is equivalent to the safe navigation operator in Apex. You are able to do it, to use it as of today. But bear in mind that the browser in which your Salesforce instance is being visualized or your application is running needs to be able to understand this, which is often the case also if you are using a modern browser. Great. So now let's talk about polyfills. So we have talked about syntax features and how they are transformed, right, to ECMAScript 6 or ECMAScript 5 to ensure backwards compatibility in some cases. But what about polyfills? A polyfill is no more than a replacement for an API that doesn't exist in the browser. So let's say that you want to use bigint or promise.any. Bigint is I think it's a class or an interface that comes with ECMAScript 12, and any is a function on the promise class that you can use also from ECMAScript 12. So by default, it may happen that your browser doesn't have those features, but ourselves or someone else can provide a polyfill that is loaded at runtime and that implements those features for you. So why do I explain what polyfills are? Because in Lightning Web Components, when we are on runtime execution, we are going to detect the browser in which you are running the application. If your browser is a modern browser, then the ECMAScript 6 version of the code is going to be loaded. But if it is an older browser, those browsers that don't support ECMAScript 6 features, then we are going to load the ECMAScript 5 versions plus the ES6 polyfills that replace those ECMAScript 6 features that are not APIs, that are not available in the browser for you. What does this imply? Well, if we ask ourselves if you can use an ECMAScript ESXX API that we are not polyfilling in Lightning Web Components, the answer is going to be very similar to the one I gave you before for syntax features. Yes, you are going to be able to use them as long as your browser and local service supports it, because sometimes we don't make an API available on purpose because it's a security feature, something that is going to be a security breach for us or something or similar cases. Great, so from the list that I provided before, I have also some other APIs that come in the most modern versions of ECMAScript that, as of today, you can use in your Lightning Web Components, even though we don't provide a polyfill, as long as your browser supports them. And we're going to see these features in detail in the next webinars. If we think about Lightning Web Components open source, there are some details to bear in mind. So first of all, we are not going to, when you compile your Lightning Web Components application, right, locally, we don't perform linting or polyfilling. Polyfilling doesn't happen on compile time. Indeed, that's going to happen at runtime, but we are not going to load polyfills for you. We are not going to generate the ECMAScript 5 compatibility output, and local server doesn't run when using Lightning Web Components open source, right? So there are some small details that you need to understand in what regards to which ECMAScript features can I use outside of the platform, because there are a couple of more features that you can use. This is the full list of features that I mentioned before, and here I have added in light blue some features that are available also for Lightning Web Components open source, because local service is not preventing their usage. So today I don't want to give you more details, but I'm going to share very quick 2 applications I have created and 2 applications that we are going to use during the following sessions of this webinar series. The first application is an application that works on the platform, and here we have examples for all the different features that I have added in that table. These may be syntax features or APIs, right? But everything is explained is in this application, and this is something that you can clone already and take a look if you wanna do it. But I will spend some time explaining every individual example here, and we have all the features that can be used in Lightning Web Components from ES9 to ES12. Then I have a second version of the app, which is an app built with Lightning Web Components, open source, same set of examples, plus a couple more. Because remember that outside of the platform, we don't have local service and we can do some more things. Also, I leave you here a link to a trail in Trailhead, which is called Working with Modern JavaScript, something like that. That if you haven't done it yet, please take a look before the following sessions, because this explains all about ECMAScript 6 features, that major update that every JavaScript developer and Lightning Web Components developer should understand, and it's going to be very helpful if you take a look at this Trailhead trail in advance before going into the next webinar sessions. And that's all for today. Thank you so much for joining. I wanted to share some of our social channels if you want to connect with us. If you are watching this video in YouTube, make sure to subscribe to our channel and ring on the bell to receive notifications. And in some weeks, I will publish the next webinar. Thank you so much. I hope that you enjoyed. And I will be for some minutes in the chat window answering 4 questions if you have any. So thank you so much and see you in the next webinar. Bye bye.